Good afternoon, everyone. This presentation is for RC.2 true set 3 salt behavior in molten salt reactors. We have changed the emphasis on the first two area, 2.1 and 2.2, and we add a new subtopic 2.3. So we'll go through that later on. So my name is Stephen Kung. I'm your federal point of contact. Here's my phone number and email address. Our technical point of contact is David Holcomb. You can have his phone number and email address here. Also listed below is our management team. And also I need to mention our Material and Chemical Technology Office Director, Patricia Pravia, is also part of management team. Okay, next slide, please. In slide 2, our objective is to support innovative research at the university that may offer enhanced safety, functionality, and affordability of molten salt technology. Our planned path forward is to establish core competency and R&D capabilities in molten salt chemistry at DOE National Laboratory as well as U.S. universities. So our second goal is we wish to train broad-based next-generation expertise. And the third one is, in working with our university communities, we want to provide a technical basis in coordination with MSR developers for supporting the U.S. industry's goal for commercialization of MSR technologies. Next slide, please. In slide 3, in April this year, the Office of Nuclear Technology Research and Development sponsored the molten salt chemistry workshop at Oak Ridge National Laboratory. Afterwards, a report entitled Technology and Applied R&D Needs for Molten Salt Chemistry is published. As listed here, you may see it is available to download from the list address above. The workshop is co-chaired by Dr. Dave Williams and Dr. Phil Britt of Oak Ridge. The report identifies 6 priority research directions. The first one is to understand, predict, and optimizing the physical property of molten salt. The second one is understanding structure, dynamic, and the chemical property of molten salt. So the first one is we want to modify and tailor the salt property to our needs. And the second one is to understand the fundamental knowledge, to gain the fundamental knowledge for modeling and provide database. The third one is understanding fission and activation product chemistry and the radiation chemistry. And the fourth one is understand material compatibility and interfacial phenomena. And the fifth one is guiding next generation material for molten salt reaction. And the last one is generating a virtual reactor simulation. So our solicitation is mostly based on this report, especially on the top 4 priority research areas. So we'll go back to that point later on. Next slide, please. In slide 4, we expect the outcome of this project, the new NIA project. We hope to engage top talents from broad university communities to advance molten salt science technology. Your proposal should focus on innovative approaches to transform the performance and the efficiency of molten salt technology, to further reduce technology cost, technical risk, and uncertainties, to lead new breakthroughs, and to inspire and provide training for future MSR researcher and developers. We do hope you can capitalize on recent breakthroughs in nanoscience and technology, advanced characterization tools and instrumentation methods, and computation and predictive modeling capabilities. Next slide, please. Slide number 5. The first solicitation subtopic, RC 2.1, predicting the chemical speciation, structure, and dynamic of salt solution for molten salt reactor. We encourage proposal to develop and use first principle molecular dynamic simulations and computational electronic structure methods to extend and limit experimental data set in covering a broad range of chemical evolution and environment. Specifically, we hope to better understand, predictive, optimize, and the physical properties, thermochemical behavior of molten salt. For example, we like you to help us to build a multi-component model for prediction of phase diagram, a thermophysical and thermodynamic database. Apply molecular dynamic simulation to predict thermophysical and transport properties that include heat capacity, thermal conductivity, and so on. And to develop innovative methods to validate thermochemical database. Basically, we hope to develop using model to guide the experimental activities. So then we can manipulate the thermophysical and thermochemical properties for our needs. Next slide, please. In slide 6, the RC 2.2, focus on fuel salt irradiation capabilities. MSR presents a number of extreme environmental demands on reactor structure, functional materials. Complex process and the impact due to radiation effect at interface must be understood and controlled to ensure long-term material reliability. For that reason, we seek proposal to better understand material compatibility and interfacial phenomena to accelerate the rate and decrease the cost for fuel salt irradiation. Topics we like to including the following. Understand material compatibility in molten salt reactor condition. Understand and control degradation process at interface. Understand combined effect of chemistry and the radiation at the interface. Predict liquid solid and liquid gas interfacial interactions. And next slide, please. In slide 7 is the news topic RC 2.3, entitled Understand the Structure and Speciation of Molten Salt at the Atomic and Molecular Scale. It is important to understand how the structure and the dynamic of molten salt impact their physical and chemical properties. We hope to determine the speciation of salt component as well as the local and intermediate structure at operationally relevant temperatures. Real-time spectroscopy and electrochemical methods can help monitoring key chemical species in solution, allowing for optimization of reactor performance and lifetime. So proposal are requests to take advantage of recent breakthroughs in advanced characterization tools and the instrumentation method in conjunction with computation and the predictive modeling capabilities. Specifically, example here are determining salt molecular structure using scattering and spectroscopy methods. Develop novel electrochemistry and spectroscopy methods for online monitoring and predictive modeling. Develops molten salt optical basicity scale to determine corrosivity and solubility of actinide. Next slide, please. And the last slide, slide number 8. All of the subtopic we list above should be covered in the report. Please, we encourage you to review the report before preparing the proposal. If you need to receive an electronic copy, please contact me. I'll be happy to send you a copy if you cannot download from the website. We appreciate your support and interest in helping us to advance molten salt technology. And now I'd like to open for possible questions. Thank you. Drew, are you there?
Yes, we are. We will take questions over the next few minutes.
Okay, first question. For RC 2.1, the details provided just now in the presentation are not reflected in the text for RC 2.1. In fact, the text is unchanged from the draft provided some weeks ago. We're going to review that here in the room. Hang on one second.
It should be similar. The goal here is to predict chemical speciation, structure, and dynamic of salt solution for molten salt reactors. For questions for the details, you can go to the workshop report for details. The goal is to enhance our database using thermochemical and thermophysical database. So we hope using a fundamental approach to enhance the database. I hope that answered the questions here.
Do proposals for RC 2.1 need an experimental component?
Yes, that would be great. And the goal, as I indicated, is to develop model to guide the experimental activities. If you can combine both to validate your model, that would be wonderful.
Okay, next question. For molten salt research, are you interested in multi-scale modeling approaches such as DFT, MD, etc.?
Sure, that's covered in our report as well.
Under what kinds of conditions do we need to apply for NSUF 1 or 2 NEUP programs?
Say it again, I'm sorry. Under what?
So this scope does not apply to the NSUF1 or NSUF2. If you want to refer to those NSUF work scopes, as Greg discussed earlier in, I think in the previous hour, those do need a NSUF access request, which is due on November 8th. More details can be found in the FOA about what that NSUF access request is.
All right, thank you, Joe.
Can any computational-only proposals be submitted to the call?
Sure. But we will evaluate the most valuable proposal for funding because we may have limited resource here.
I assume we should take our cue from the presentation together with the text of RC 2.1, which does not cover all the topics in the text. Is that correct?
Yes. The presentation provides more technical details of the examples.
Okay, here's one more question just came in. Were any computational proposals funded for the thermal radiation transport in the last NEUP call?
I can't answer that. I wasn't involved last time.
Yeah, all of those funded proposals are available on nup.gov. If you go to R&D, underneath the 2017 call, you can look through the fuel cycle and the reactor concepts calls there. All of that information that's publicly available is all that we are able to share about last year's process. And for anybody who has specific questions about a work scope area and can't find it on the website, please contact me at drew.thomas@inl.gov and I can help you locate that information.
All right, thank you, Drew.
And to answer a general question that several have asked, all of these slides and the recording of this webinar will be posted to nup.gov as soon as possible. So we'll be working hard for the remainder of the week to make those presentation materials available so that you can start on all of your applications. All right, Stephen, that looks like all of the questions that we have. Thank you for joining us.
All right, thank you, Drew. So I'll sign off.
Thank you. And thank you all for sticking with us through the late schedule. As a quick reminder, we wanted to run through all of the dates for both FOAs that opened last week. I just want to remind everyone that the CINR FOA, which was discussed today, opened last Thursday. That's FOA 1772. There was another FOA that opened, that's the University Infrastructure, Consolidated Infrastructure or Scientific Infrastructure Support Solicitation. That's 1773. Applications for the infrastructure FOA are due on November 30th, so please be aware of that due date as well. Due dates for the FY 2018 CINR, I want to quickly go over those. November 8th is the due date for all NSUF access requests. That's for NSUF 1, NEAMS 2, and NSUF 2. As I said, infrastructure applications are due on November 30th. NSUF 1 and NEAMS 2 invitations will go out around December 19th. The NSUF 1 and NEAMS 2 statement of work are due on January 12th of 2018. Those will be appended to your NSUF access request on the nup.gov website. Full applications for all research and development scopes except for NSUF 2 are due on January 23rd, 2018. And then NSUF 2 full application invitations will come out around March 20th, 2018. Final statements of work for NSUF 2 are due on April 26, 2018. And finally, the NSUF 2 full applications will be due on May 17, 2018. As was discussed in the initial presentation, the expected award dates for all applications that are not NSUF 2 is in the first week of June 2018. NSUF 2 applications will be released at a later date, but it is expected that they will be announced before the close of FY 2018. Once again, we'd like to thank you all. If you have any questions about this webinar or about other questions concerning the CINR or infrastructure FOAs, please direct those to nup@inl.gov or feel free to call one of the numbers listed in the FOA to answer those questions. Thank you.